Building highly available web applications. A highly available system minimizes service interruptions and enables resources to be available when they are needed. Unfortunately, system failure is unavoidable. External factors beyond your control may eventually affect your services. Causes of system failure include natural disasters, hardware failure, or malicious security events, just to name a few. These events can have severe implications for your operations and can cause disruption of mission-critical systems, resulting in degradation of system performance or complete failure. Moreover, without proper design considerations, failure of an application in one region may have global impact. These outages cause customer dissatisfaction, which can lead to a lack of confidence in your services and, ultimately, a downturn in revenue. Fortunately, with AWS, the effect of these scenarios can be mitigated by building a solid foundation in AWS's cloud architecting principles, and with careful planning and design, AWS can help you create a highly available application which meets your needs. Principles for architecting high availability. Designing for failure. A system will eventually fail, therefore, you must design with this assumption in mind. If a component fails, the system must continue to run. This is known as fault tolerance. One of the simplest manners to improve the fault tolerance of your system is by introducing redundancy. When you are creating redundant systems, consider spreading your services over multiple regions or availability zones. This will further decrease the probability of overlapping incidents. Embrace elasticity and automation. AWS provides you with the capability to monitor your resources using AWS CloudWatch. With CloudWatch, you can track metrics such as CPU, disk, RAM, and network usage. With these metrics, you can introduce elasticity into your system with services such as auto-scaling groups. Auto-scaling groups allow you to create a set of rules to automate the provisioning of your system under different loads. If your systems are overloaded, they can scale out. Alternatively, if they are underutilized, you can scale in. In this way, you can configure your systems dynamically. Another architectural consideration is to ensure that your system has the ability to auto-heal when a service encounters trouble. Should a service become unresponsive, you will need to automatically provision a new service. Loosely coupled components. Another principle is to ensure your systems aren't highly dependent on each other. This is known as tightly coupled. When you have a set of tightly coupled services, should one of them fail, it can cause a domino effect which can cause the whole set of services to encounter a fatal error. Instead, seek to decouple your components from one another. You can use services such as Elastic Load Balancer as an intermediary, routing traffic to a black box of eligible services. Another service can be Amazon Simple Queue Service, also known as SQS. SQS can enable one set of producer services to send messages to a set of consumers without having to worry if the consumers are active or healthy at the time when the message is sent. Become stateless. Stateful applications hold information regarding the state of an individual user on a server. This could include login information and file transfers. This is problematic in the case where a server fails, since state information isn't shared across all servers. This means our data is tightly coupled, so we're already losing a highly available quality. Instead, when possible, consider using a stateless protocol. With a stateless protocol, often seen with RESTful services, state is not held on the servers, but are held by the user in various forms, such as tokens. State information can also be held by other services, such as DynamoDB or Elasticache. In this scenario, when a server fails, there is no interruption in service. Use parallelism. A monolithic application is a piece of self-contained software which has multiple distinct components bundled together. This piece of software will receive data for all the components and perform the necessary operations on it. This can severely reduce performance, as the system attempts to handle varying requests. Moreover, it is not uncommon to see subcomponents unnecessarily placed in a linear pipeline. This can create a bottleneck for task completion, where the longest subtask delays loosely related tasks. At every opportunity, you should transform these applications into smaller, independent, parallel services. These small services are aptly called microservices. Each microservice will receive data pertinent to its function. Furthermore, these services can allow you to scale more granularly. Overall, this decreases the chance that any one component can cause failure of the whole system, thus increasing the overall availability. Security is a forethought. Finally, it is important that security is considered early and woven into every layer of your system. Remember to follow security best practices. These include but are not limited to setting up governance and compliance, encrypting your data in transit and at rest, monitoring your resources, environments and incidents, and following the principle of least privilege.